I thought about saving this one for the weekend, but we're going to trudge on. 427 on Thursday, November 2nd, inequalities with absolute values. So these get tricky. And what I've been trying to impress upon you is this sign, this inequality is a less than. So that means less than is associated with and. So we know it's going to be an intersection, and we also know that it has to be true, true. So we're going to separate. And we also have to remember, so we have to remember multiple things starting right now. And we know that inequalities, that this can be negative or positive within there. So we're going to write two statements. We're going to write y plus 2 is less than 8, and we're going to insert that and at this stage. Y plus 2 is greater than negative 8. Mr. Mack, you flipped the sign. Yes, because I did the negative side of it. And if it's negative to both inequalities, you have to flip the inequality sign. So that's where this gets tricky. So we subtract 2, we get y is less than 6, and we subtract 2, y is greater than negative 10. So if we had to graph this, so if we had to write it as an inequality, it would be negative 10 and 6. You put your variable, and then we want less than and less than. Does that associate? Yes and yes. So that still satisfies both of those solutions. That is a correct way of writing the inequality as an and. It is numeric, and we're using less than. So now let's graph this. Negative 10, 0, 6. We have open circle going in between. Let's make sure our inequalities, yep, we're good. So those are the solutions to the absolute value. Not too bad, right? So there are a couple things. Okay, so let's look. We're going to write it. This is greater than, so we need to remember, well, we have to know that greater than is an or statement. Less than is and, greater is an or. So we're going to write two statements. Q divided by 3 is greater than 2, or Q divided by 3. We're going to flip the inequality sign and change the sign of that right number. And now let's solve it. So we're going to multiply both sides by 3. We get Q is greater than 6, or let's multiply both sides by 3. We get Q is less than negative 6. So what does that look like? Negative 6, 0, 6. Q is greater than 6. That's an open circle going to the right. Q is less than negative 6 going to the left. Since it was an or, we expected to get the oars paddling the boat. And that looks pretty good. Okay. Awesome. Let's see. Oh, whoa. So, first place. First thing, look at that problem. I want you to ask yourself, what is the first thing that I need to do? I'm going to write this, and hopefully it gives you flashbacks and crazy, oh my goodness. What do you think I'm going to write here? Isolate the absolute values first. So we have to get rid of this stuff before we do all of those weird less than, greater than, or all that stuff. So what are we going to get rid of first? We're going to subtract 10. That gives us 3 times the absolute value of 2a plus 5 is less than or equal to 27. We're going to divide by 3. And that gives us the absolute value of 2a plus 5 is less than or equal to 9. Now, whoa, look at that. That was kind of cool. Now, what's our inequality? Have we isolated? Yes, we've isolated the absolute value. Now we're going to look at the absolute or the inequality. That inequality is less than. Less than, so, or less than or equal to. So that is going to be an AND. So when we write these two statements, 2a plus 5 is less than or equal to 9, and 2a plus 5 is greater than or equal to negative 9. We're going to flip that inequality sign when we flip the negative sign. So minus 5, 2a is less than 4, divide by 2, a is less than 2, and minus 5, 2a is greater than or equal to negative 14, divide by 2, a is greater than or equal to negative 7. So let's write it, see if it works. A in there, that is a less than, and that points to negative 7. Okay, good. So that's correct. Let's graph it. Negative 7, 0, 2. We have a closed circle, greater than, closed circle, less than. Oh yeah, that looks good. We just done good. All right, our absolute value is isolated, so I don't have to do any work. I'm looking, it's less than, so that means and. So I'm going to write y minus 3 is less than 4, less than or equal to 4, and y minus 3 is greater than or equal to negative 4. Good. Let's add 3. Y is less than or equal to 7. And let's add 3. Y is greater than or equal to negative 1. So negative 1, 7, y less than or equal to, and less than or equal to. Let's graph it. Negative 1, 0, 7, closed circle, greater than, closed circle, less than, and that would be my solution. Yep, that looks good. All right, so we have to isolate first before we do anything. Let's get this absolute value by itself. Okay, it's less than, so it's going to be an AND. So 3 plus r is less than 4, and 3 plus r is greater than negative 4. Minus 3, r is less than 1, and minus 3, r is greater than negative 7. So negative 7, 1, r, less than, that's good. I know that's correct. 0, 1, open circle, open circle. Cool. All right. This should be getting pretty easy. You should sort of feel confident about your work. So this is greater, so it's going to be an OR. So we're going to write 2 of them. F plus 12 is greater than negative 4, or F plus 12 is less than positive 4. Minus 12, F is greater than negative 16, or minus 12, F is less than negative 8. So it's an OR statement, so I don't have to write it as 1. Let's look and see what we get. So negative 16, negative 8, and 0. So F is greater than negative 16. That looks like that. F is less than negative 8. That looks like that. This is an or, so we need at least one, and we see that overlapping. So or is one, at least one true. So we have one true here, we have one true here, we have two trues here, we have one true here, one true here. So if we're going to graph that, that's going to look like this. It is all real numbers. That would be my answer to, and we have to do this graph. I need both of these things. I need the graph and the statement, all real numbers. All right, so we have less than a negative number. Less than is going to be an and. So I should already know. What do we know that's going to come out of here? Is there going to be a positive or negative number that comes out of here? No matter what I plug into x, whether it be a negative, 0, positive number, what's always going to come out of an absolute value? No matter what value I plug in for x. It's always going to be a positive number. So do we notice this? That a positive number will never be less than negative 2. So I already know this answer is going to be no solution. Well, let's not write it there. Let's write it here. No, no solution. But let's see what happens if I don't notice that. So we know it's an and. So let's do x over 4 minus 7 is less than negative 2, and x over 4 minus 7 is greater than positive 2. So let's solve. I just want to see what happens if we keep going and it's going to still take us to something that is going to produce no solution. Let's multiply, not by 5, by 4. So we get x is less than 20, and we're going to add 7. X over 4 is greater than 9. Multiply by 4. X is greater than 36. So can you have x? Yes, good. So it would still, even if you didn't see that logic component, if we graph this, x is less than 20, x is greater than 36, and it must be true, true. There are no true, true. There is no overlapping. So again, we would come up with no solution. Even if we did it out, there's a fail-safe telling us that the answer is no solution. I like that. That's reassuring. So we have this absolute value. Our first step is to isolate the absolute value. And that gives us 9. It is greater than, so I know it's going to be an or. 4x minus 7 is greater than or equal to 9, or 4x minus 7 is less than or equal to negative 9. So those are my two statements that I have to produce. Plus 7, 4x is greater than or equal to 16, divide by 4, x is greater than or equal to 4, or add 7, 4x is less than negative 2, less than or equal to negative 2, divide by 4, x is less than or equal to negative 1/2. Make sure you simplify that fraction. So we have negative 1/2, 0, 4. So x is greater than or equal to 4, close circle. Going to the right, x is less than or equal to negative 1/2, close circle, going to the left. So that's a pretty straightforward problem. No trickiness there. Trickiness here, I guess there is trickiness, is we have to isolate first. 3 minus k is greater than 0. Divide by 6. We have 3 minus k is greater than 0. 0 divided by 6 is 0. It is a greater than, so this is going to be an or. So 3 minus k is greater than 0, or Oh, 3 minus k is less than 0. We wouldn't write negative 0, but we're taking the positive and negative. So let's subtract 3. Negative k is greater than negative 3. Divide by negative 1. K is less than 3. Or subtract 3. Negative k is less than negative 3. Divide by 1. K is greater than 3. Oh, yes. Look at this one. Let's go. So let's graph that. Well, let's write our numbers. 0, 3. This is such a cool answer. So this is k is less than 3. Open circle, going to the left. This one is k is greater than 3. Open circle, going to the right. Now remember, or is at least 1 true. So where is there at least 1 true? Do we already know what this solution is going to look like? Hope you do. That would be very intuitive if you did. Let's be open circle. So it's every number but 3. How cool is that? So you need an open circle over 3, and you need arrows going left and right of it. Very cool. Love that. I will not accept this. Do not give me that as a solution. I will minus a point off. How many people are going to do that? What do you think? 10? What do you think? The over-under is 10? On the quiz, I'm going to take the under. We'll see. I believe in you. But we'll see. Don't disappoint me. Oh, baby, look at this crazy stuff. Oh, this is so good. Another great problem. All right, remember, we got to isolate first. Let's get rid of that negative 2.8. That gives me negative 4 times the absolute value of 3 minus 2m is less than or equal to negative 8. Then we're going to divide by negative 4. We haven't isolated the absolute value yet. Oh, this is the cool part right here. So that leaves me with the absolute value of 3 minus 2m is greater than or equal to 2. So it just changed from less than to greater than. So that is going to be greater is or. So we have an or statement now. So we have 3 minus 2m is greater than or equal to 2, or 3 minus 2m is less than or equal to negative 2. Minus 3, negative 2m is greater than or equal to negative 1. Divide by negative 2. What? We got to flip again? Or minus 3, negative 2m is less than or equal to negative 5. Divide by negative 2. And we get m is greater than or equal to 5 halves. Let's go. That's some crazy stuff. Lots of things to mess up on. 0, 1 half, 5 halves, open circle, no, closed circle, m is less than 1 half, and m is greater than or equal to 5 halves. Okay, no one so crazy. There were just steps for you to make mistakes within it. So be very mindful, be careful, check your work, take your time. All right, now it says write the sentence as an absolute value. Then, I would assume, I don't know, oh, I bet you I know where it is. Whoop, then solve the inequality. Peekaboo. A number is no more than 10 units from 6. What? A number is no more than 10 units. So the absolute value of x I'm going to say no more than 10 units from 6. Well, all right, let's do this. Let's think about this logically. So no more than 10 units from 6. So you got 16 and you got negative 4. Right? That's no more than 10 units. This is 10 units. and this is 10 units. So remember, that was my middling, so 6 is going to be the outside number, and it needs to be, oh, it's an intersection, so we know it's going to be less than, so it can be equal to it, and then we're going to have the absolute value of x minus 10. I like minus 10, so, oh, so close. It's going to be the other way, sorry. X minus 6, that distance, yes, the distance from the number and 6 needs to be this length. The length, sorry, this is the length, this is the middle. So the length always goes on the outside. So that is the proper way to do it. Sorry, I forgot that little part. Of course, this is the length, right? Because that's what we're measuring. So if we have this, we know, as we stated, that's an and. So you have x minus 6 is less than or equal to 10, and x minus 6 is greater than or equal to negative 10. And we kind of already see what our solutions are, but it's okay. Plus 6, x is less than or equal to 16, which we kind of knew. And add 6, x is greater than or equal to negative 4, which we already kind of knew. So my solution is going to be, and this is and, so let's write it as a statement, negative 4, 16, x in the middle, less than or equal to, less than or equal to, and that is my inequality. Does it say write and graph? Then solve the inequality. It doesn't say anything about graphing, so that would be my solutions. The values that are no more than 10 units from 6 are the values of negative 4 through 16. All right, good little challenge. Half a number is more than 3 units from 8. So no more than 3 units, so that's my distance. So I know that's going to be 3. From negative 8, half a number. From negative 8, is that? Yeah, I feel like that's it. And half a number is more than 3 units from negative 8. So it has to be more than. So we're going to have, well, let's, that's what it is. But let's think about it logically again. Let's do this. So tell me, right, half a number is more than 3 units from negative 8. So if we have negative 8, and it has to be more than 3, so, no, sorry, that's 5. So it has to be more than, so we're going to have an open circle going, and right, these values are more than 3, and 1, 2, 3, which is negative 11, and we're going to take those values. So I know that it's going to be an or, so since it's an or, I know that it has to be greater than. So that's how I knew that it was 1/2 n plus 8 absolute value is greater than 3. So I kind of knew that we were going to get into that situation. So there were pieces that I knew. We knew it was an or because of my solutions. So we have 1/2 n plus 8 is greater than 3, or 1/2 n plus 8 is less than negative 3. Minus 8, 1/2 n is greater than, I think that's negative 5, multiply by 2, and we get n is greater than negative 10, which we kind of knew. Oh, negative 10, 8, 9, 10, 11. 5, 6, 7. What did I do? Did I do? Oh, no. Negative 10. Why is that? Oh, 3 units from negative 8. 9, 10, 11. Oh, I didn't do the half a number. Sorry. Yes. So I was just taking this part. Sorry, this is kind of incorrect, but meaning our solutions aren't going to be that because I forgot about the half. I was just trying to position. The reason why I did that number line thing was just to see how we move off of it. So sorry about that. That was kind of confusing because we didn't do the half part. But we kind of did. -5 doubled would be -10. And then this is -11 multiplied by 2. And we get n is less than -22. And there's doubled would be -22. So that was okay. It's just I forgot that one piece. All right, this is an OR. So that would be our answer. And then if we had to graph it, which it doesn't want us to graph. So, and it doesn't have to be in numerical order in the OR statements, but that's how they did give it, but it's okay. Number 13, we got a couple more. We're still rolling along here on a Thursday. At a company, the average starting salary S for a new employee is $42,000. The actual salary has an absolute deviation of at least, at most, $1,800. Write and solve an absolute value inequality to find the range of starting salaries. So has an absolute deviation of at most. So we can either go plus 1,800 from my 42,000, or we can go minus 1,800 from my 42,000. So my distance is 1,800, and it needs to fit within this. So I know I'm in at most, so we can do less than or equal to because it's going to be a segment, and we're going to do the absolute value of X or S salary, and we're going to do minus 42,000. So I'm pretty sure that is my inequality. Wow, I'm getting pretty good at that. So that is my inequality. And then solve. Yeah, that was pretty good. So hopefully you are also getting good at that and you see the simplicity. So S minus 42,000 is less than or equal to 1,800. And because it's less than, S minus 42,000 is greater than or equal to negative 1,800. And we now see where that negative 1,800 comes from. Why we do the positive and negative of it. Because we can move in both directions. Sorry, that was really bad. Oh, that's very interesting. I know what you're saying. Shouldn't the negative be here and the positive be here? Yeah, it's so weird. Yeah, yes, you can. Since we're talking number lines, that would make more sense. I was moving 0 to, isn't that weird? When I go increasing, I go right to left. That just was really bizarre. Sorry about that, kids. I just found something out about myself that makes no sense. S is less than 4,3,800. And add 42,000. Add 42,000. S is greater than or equal to, and that is 40,000, 40,200. I think that's what it is, 40,200, yep. That's an end statement, so we can write that 40,200 is less than or equal to S, which is less than or equal to 43,800. That would be the representation of the salaries that would work within that deviation. Oh, what a good term. A nail manufacturer throws out nails with lengths that are not within 0.5 inch of mean length of the batch. The lengths in inches of the nails in a batch are 0.42, 0.53, 0.55, 0.48, and 0.51. Which nails should be thrown out? Okay, so step one is let's find the mean of that batch. So 0.42, 0.53, 0.55, 0.48, and 0.51 divided by 1, 2, 3, 4, 5. Let's get the handy dandy calculator. Right. Let's do this. Let's do C, 0.42 plus 0.53 plus 0.55 plus 0.48 plus 0.51 gives us a total of 2.49. 2.49 divided by 5 divided by 5 gives us 498. Are there any thousandths, lengths in inches? Mean length, lengths, inches. Okay, everything's cool. So 0.498. So the values, let's do this. So the length is what is my variance tolerance? 0.05. 0.05 needs to be, it needs to be within that. So it needs to be less than or, let's see, within. So I don't think it's equal to, I think it has to be less than that, would be my guess. And it's going to be the nail length minus 0.498. So if we solve that, less than is and. So we get n minus 0.498 is less than 0.05. And n minus 0.498 is greater than negative 0.05. So let's add 0.498, add 0.498. N is less than 0, that's 8, that's 4, that's 5. And we'll add 0.498, add 0.498. So we have to rewrite it because you can't take a bigger from a smaller. So 0.498 minus 0.05. That's 8. That's 4, 4, 0. So, and n, greater than 0.448. So the tolerance, so my nail length needs to be between so of those values, which ones are between 0.448? So let's look at my list again. So 4.2, that's not within it. So 4.2 is a no-no. 5.3, is 5.3 between that? Yes. Is 5.5? Let's see. Nope, 5.5 is outside the tolerance. 4.8. 4.8. Yep, that's within the tolerance. And 5.1. I think 5.1 is also between the tolerance. 5.1, yeah. So the two nails that would be no bueno is 0.42 and 0.55. Yeah, let's go. That was pretty awesome. Pretty happy with myself. The difference between the areas of the figures is at most 6. Write and solve an absolute value inequality that represents this situation. So let's represent it. Difference in areas. So we have the area, the difference between the areas of the figures at most. So the absolute value, the area of the rectangle minus the area of the triangle is at most. So it has to be within it. So it's going to be less than or equal to 6. I like that. So that is the real brunt of the problem. So let's see Now let's fill in the information. So the area of the rectangle would be length times width. The length is x plus 2. 4 times x plus 2 would be the area, right? Because we're talking length times width. And then the triangle's formula minus the triangle is going to be 1/2 base times height. So 1/2, the base is 5 times the height, which is 4. Absolute value less than or equal to 6. Okay. So let's simplify now. We get 4x plus 8. Before we distribute this negative, we're going to have to distribute, but let's simplify this. 1/2 of 4 is 2, so minus 10. That's 20. 20 times 1/2 is 10, and then the negative. So let's still simplify. We get 4x minus 2 less than or equal to 6. So that would be my equation. That is the equation simplified. And now we're going to solve it. That's an and. So we get 4x minus 2 is less than or equal to 6. And 4x minus 2 is greater than or equal to negative 6. Add 2. 4x is less than or equal to 8. Divide by 2. X is less than or equal to 4. And add 2. 4x is greater than or equal to negative 4. Divide by 4. X is greater than or equal to negative 1. So that's going to give us some very interesting situations here. So if we had to write that, and 4 with my x less than or equal to, less than or equal to. My concern is that x is a negative number. And we know that we can't have negative distance, but is negative 1. X doesn't represent a distance at the moment. This is negative 1 to 0. And that would never produce a negative distance. You see what I mean? So we can accept that constraint or those limits. We can accept that for x because that would not put us into a negative distance. If we do the extreme, which is negative 1, negative 1 plus 2 would still give us a distance of 1. So that's okay. So be careful of that. It's something that we would need to consider and keep in mind. All right, I like 15. 16, write an absolute value inequality for the graph. Well, since it's wings, we know we have to have or. And since it's or, we're going to have greater than. Now, what is that distance? What's the middle? The middle would be here, and there's a distance or a length of 2. So we're going to have 2 here. And then we have to get a value. Let's do x. Let's do, it can be closed circle, sorry, because it's equal to. Let's do x plus 1. Okay, so let's see if that produces it. Yeah, I think that's it. I do think that that is it. That's greater than, so you get x plus 1 is greater than or equal to 2, or x plus 1 is less than or equal to negative 2. Minus 1 gives us x is greater than or equal to 1, which is this part. Minus 1, you get x is less than or equal to negative 3, which gives us that. So that worked. So this is our absolute value. Last one, solve the compound inequality. Oh, okay. So I see 4 things that we have to solve for. So let's do this first. Let's do this one. So that is greater than, so it's an or. X minus 4 is greater than or equal to 3, or x minus 4 is less than or equal to negative 3. That's cool. Plus 4, x is greater than or equal to 7, or plus 4, x is less than or equal to 1. So that's one of the solutions. Okay, we're okay with that, right? And now let's solve this one. This is a less than, so it's an and. So we get x minus 3 is less than 5, and x minus 3 is greater than negative 5. Add 3, x is less than 8, and add 3, x is greater than negative 2. So that looks like negative 2, 8, x less than. So I have solve the compound. So, oh, and they both, what? Okay. Now we also have to keep in mind this and. So it needs to be true for both of these. So let's solve it. All right. You've got me. You've got my attention. So let's graph them. Let's graph the solutions. Let's graph the green ones. Let's get our numbers down. So we have negative 2, we have 0, we have 1, we have 7, and we have 8. So let's graph the greenies. So x is greater than or equal to 7. So that's a closed circle going that way. Or x is less than or equal to 1. So those solutions look like that. Okay. Now let's do the blues. So open circle at negative 2, intersection to 8. Now we need to find out where are the true trues. Where are there two trues? So I'm going to graph it, and then maybe I'll write an inequality representing it, because I think the graphing is cooler. Negative 2 to 1, well, let's do 0, 1, and then from 7 to 8, because this is 1 true, this is 1 true, this is true, this is true, this is 1 true, this is true, this is true, this is 1 true, 1 true. So where we have two trues is going to be between here and between here. How cool is that question? Oh my goodness. So we're going to have open circle to 1, closed circle, and then we're going to have closed circle to open circle there. So can I write that as an inequality? So I would write that as negative 2 is less than or equal to x, which is less, or not less than or equal to, less than to 2, less than or equal to 1, or 7 is less than or equal to x, which is less than or 8. Oh my goodness, let's check and see if that's our answer. Woo-hoo-hoo! Today was a good day, folks. That was spot on. Those were two really good videos. I'm really liking, that was number 17. Wowzers. You want to be good? Work on those problems. Challenge yourself. You're only going to get better by testing your limits. Awesome job. Hopefully you had fun with this. Hopefully you learned something. And have a great afternoon.